Final talk for this session, Kim Carter, doesn't need much introduction, aka BinaryMist, and he'll be talking about building Purple Team. Over to you, Kim.
Hey everyone, thanks for that. Couple of, three Twitter handles there. purpleteam-labs is basically what the talk's about today. BinaryMist Books is the Twitter account behind the books that I publish, and BinaryMist is just my personal Twitter account. So our sponsors, a lot of these sponsors have been with us for quite a few years. It's the odd new one in there. I'd like to really thank them because we wouldn't have the conference otherwise. And I'd also like to give a big thanks to Pete Nichols of Trinio, who recently came to the party. Who recently came to the party for the OWASP New Zealand chapter venue, because we've lost our venue recently, and so Pete stepped up with the place where he works called Trinio, and so now we've got our got a meet-up venue back again for Christchurch. So this is just the talk structure, give you an idea of what we're going to be running through. So we're going to be running through the proof of concept, what my intentions were, what I was trying to achieve with that. That was like 2.5 to 3 years ago. It was basically just to elicit a developer feedback. How we got from the proof of concept to an alpha release, the journey. The environments involved, so there's local and cloud, and the architecture and technologies, and the pressures involved in doing a project like this. And how to get Purple Team into your hands and into your build pipelines. So the proof of concept. So if you're a developer creating internet-facing applications, you know security is something you need to be thinking about, right? So as developers, we need as much automated help with improving our application security as possible. And that's so basically no blockers, just enablers to make us go fast. I want to talk, so also, so with my proof of concept, I did a whole bunch of workshops nationally and internationally to get developer feedback, to work out whether Purple Team was actually going to be a viable thing to even start to work on and create. So as developers, we need as much help with static and dynamic application security testing as possible. So there's loads of static application security testing tools out there, but far fewer dynamic. So that was one of the reasons I decided to start down this path. Also, I'm talking with Simon Bennett, who is the creator of OWASP Zap Proxy. He was quite keen on building ZAS, which was going to be kind of what I was doing, or what I ended up doing, but it was just for Zap. So it was basically just, hiding Zap behind a SAS. So Simon didn't really have the bandwidth for it, so I decided just to pick it up and start working on it. This is nothing to do with Zap. Zap just happens to be the emissary of the application tester that we use. We could have chosen something else, but Zap's the best one. It's free and open source. So the environments. So I'm going to talk about local and then I'm going to talk about cloud. So there's quite a bit of setup you have to do with the local environment. Also, local is completely free and open source, whereas the cloud environment is not. Because everything's done for you. All you need to do with the cloud environment is set up the CLI, set up a job file. I'll talk about that soon anyway. So with the local, you need to, yes, there's quite a bit of setup to do. You need to set up all the microservices, either on your own machine or within your network somewhere. There's plenty of documentation to help you get started with it. I'm hoping it's going to be clear enough for everyone. If there's any problems, then it's all open. Submit a pull request, open an issue, whatever you need to do to get my eyeballs on it, or whoever's helping at the time. You'll need to set up a bunch of Lambda functions, some stage 2 containers. I'll talk about how all these work soon. The orchestrator itself, which, yeah, I'll show you a diagram again. This is just another microservice, but it's the beginning of where your traffic starts in the SaaS. The testers themselves, so currently there's an application tester, there's a TLS checker and a server tester as well. Those last two are stubbed out, and the application tester is the only one that's fully implemented at the moment. It's also a pluggable architecture, so the idea being is as developers work out they need additional testers, they can just add them or ask us to, or either way, a combination of both. So with the CLI, you've got to get it onto your system. You can git clone it or npm install it. Then configure it, which we're going to discuss soon. It also needs to be done for the cloud environment. And create your job file, which we'll walk through soon as well. And then run your system under test, which you're going to be attacking. And run the CLI itself. So in the cloud environment, all the infrastructure is set up for you. All you need to do is get the CLI on your system. Git clone it or npm install it. So this is the, it's the CLI config, so it's the configuration. There's a bit of config in there you'll need to set up before you basically get going, even in the cloud environment. So that's the tester progress directory name, so that's where your logs sit for the CLI itself. This is the customer ID. So these details you would have been given if you sign up for a cloud account. The API key, the API client ID, the the application client secret, the cust-in subdomain, the build user config file URI, so that's your job file, which I'll show you the guts of soon, and the outcomes directory. So the outcomes directory is where your reports get sent back to, and any other outcomes from the back end. So there's reports from the different testers and there's outcomes from the testers. Actually, the reports are from the emissaries of the testers. I'll show you this soon anyway. So that's a job file. Pretty basic one. So you've got your system under test authentication details there. Login details, how the system needs to log into, or how the application tester needs to log into your application. Contact details, whether you want it to use Firefox or Chrome or whichever browser. What report formats you'd like back, logged in indicator so that it knows when it's logged in or not. There we've got some test sessions, 2 test sessions. So most of the things I talk about through this talk I'll be referring to 2 test sessions. So I've got a low privilege user and an admin user. And now we reference some data for those test sessions. So each of those test sessions has like some creds, attack scanner strength and alert threshold. Alert threshold there is currently set to 12, which means, so for example, if you've got a brownfields project that you're working on and it's currently got 12 defects, your test won't fail until it gets over 12 defects. And then the relationships to this particular routes that you want scanned. So that low priv user is only testing the profile route, but with the admin user we're testing the memos and the profile route. And then the actual route details there, just basically fields and some dummy data to throw into them, and that's it. And that's basically all you need to get it going. And of course you want to run your system under test, otherwise you're not going to have anything to beat up. And purpleteam test, run the CLI and inspect the outcomes on completion. It's got a nice graphical GUI so you know what's happening when you run it manually. You can also run it, obviously within your build pipelines or any other application. If you look at the README on the actual CLI, it's got a whole lot of different scenarios that you can throw it into. Cool, so looking at the architecture and technologies. So again, we're going to look at local and then we're going to look at cloud. They're both kind of similar. Most of the guts of them is pretty much the same. Is that big enough to sort of see what's happening? Yeah, cool. Yeah, okay. So I've got the orchestrator here. Takes the input from the CLI. This is in your own environment. This is local. Supervises the testers. So it looks after your testers here. So here we've got application scanner, server scanner, and TLS checker, and you can add your own as you work out if you're missing something. We've got Redis in the mix there as well, which takes the tester progress events from the testers. So we're using publish, subscribe, and lists in Redis. So here you see here, for our progress events, you can decide whether you want to use server sent events to get your data, to get your messages back, or long polling. In the cloud environment, you've got to use long polling because of some restrictions in AWS. I'll talk a little bit more about those later. So if you're using server sent events, as the test progress messages are published into Redis and the orchestrator is subscribed to them, as soon as they come off, as soon as we get them in the orchestrator, we just push them straight back to the CLI. If you're using long polling, then we push those messages back into Redis lists, into specific lists for the testers, and then as a long poll request comes in, then we pop them off the list. So we pop off a whole bunch, or as many are in that particular list as are there. So it's actually, it's not too chatty here at all. It's actually, in some cases, it can be less chatty than server send events. The other good thing about long polling is that if your CLI goes offline for a while, you don't lose any messages because they'll still persist in the Redis lists. With server sent events, they're gone. You don't get those messages back. Okay, yep. So the orchestrator is responsible for the testers. The testers are responsible for the emissaries, these guys here. So for that build user config file that I showed you, or the job file, there was 2 test sessions. So in this case, what would happen is there would be 2 zaps, 2 seleniums, and 2 NICTOs and 2 SSLIs. This is just to compartmentalise all of our emissaries so that we don't get mixed results and stuff like that. Okay, yep, and your testers are responsible for starting your emissaries based on that job user config file. So here locally, we have got our Lambda functions hosted using SAM CLI, so it's all running locally. There's nothing running in the cloud here. And then we're using Docker Compose UI to host our stage 2 containers, which are started dynamically. And so our application testers spin up our Lambda functions, and our Lambda functions talk to Docker Compose, and Docker Compose hosts our stage 2 containers. So Docker Compose UI is necessary in order to get to the host's Docker socket in a clean way. It's also quite good for sort of for introspecting what's happening with your containers when you're in development, or if you want to debug some of these things. Basically everything here, I've got the ability for you to debug all of these components with very little work. So yeah, so you can debug the whole system yourself if you need to. Yep, so these, yeah, so there's some Lambda functions that spin up the emissaries, and there's some other ones that tear it down once they've finished. Cool. Okay, so with our cloud environment, we use Terraform and TerraGrunt. These are the routes that we use. So I'm not sure if you know much about Terraform. It's a declarative infrastructure as code tool with a configuration language, the HashiCorp's configuration language. So what happens here with these roots, some of these roots take inputs from the previous roots. They're numbered in order of the way they need to be run in order to build up the infrastructure. So without TerraGrunt, you've got to feed in the outputs from some of those previous roots, and you've got to do that manually. With TerraGrunt in the mix, that basically wires them all up automatically, so it's extremely easy and quick to create. This is just a matter of minutes to create the entire cloud environment. So these static roots responsible for IAM roles, policies, ECR repository creation. The network roots responsible for networks, VPC, load balancer, auth and API certificates, auth and authentication subdomain. The API auth root is responsible for the Cognito user pools, the customer specific auth subdomain. The container orchestration root is responsible for the SSH public keys, EC2, CloudWatch log groups, ECS, auto-scaling, and Lambdas. And the API root is responsible for the API gateway, CloudWatch log groups, VPC links, APIs, API subdomain, usage plans, and API keys. So this is a diagram of what our cloud infrastructure looks like built. It looks pretty similar. We've got some authentication here happening, and it's a little bit different here up front. So we go through these two components here. So again, the orchestrator organises and supervises the testers. Redis is pretty much the same deal, just that we're constrained to using long polling. So we could have used the API gateway WebSockets for bidirectional comms here. But that doesn't support the OAuth client credentials flow, and we'd already done the authentication part of the story before I implemented this in the cloud. This was the last piece, so we're sort of stuck with doing that at the moment, unless we rework a whole lot of stuff, but it works fine as it is. Okay, so the CLI makes a post request to the purpleteam auth domain with the grant type, the client ID of the user pool app client, the scopes and the client secrets, or client secret. The Cognito authorization server returns an access token, and then the app can start making requests through to the API gateway with the access token. The API gateway is also acting as the resource server. And then the API gateway just basically does token verification to the user pool. If it's all good, then it allows the request to carry on through to the NLB and then to the orchestrator. Cool, so the only difference here is that Lambda is actually hosted on Lambda. Instead of using Docker Compose UI, we're using ECS. That's about it. Originally we used application load balancer, but that didn't support our authentication requirements. So we had to back that out and rework that. So now we're using API gateway with an NLB behind it. And so ECS is now hosting our stage 2 containers. So some of the pressures. How are we going for time? We've got like 5 minutes left. Oh, excellent, cool. Okay, so the last update after I'd finished the infrastructure as code, this is just one of the issues. Shows you some of the dependencies we had to update. So there's some Terraform dependency stuff there that wasn't very hard, but the actual project dependencies, they're all JavaScript microservices, Node.js microservices. So you can see So Purple Team project, it's got all these dependencies, Purple Team Lambda project, Purple Team Logger project, Purple Team Orchestrator project, the App Scanner. That was about it. It wasn't too bad, but there were some things in there that we had to sort of rework. Docker Compose UI it kind of looks like it's not being supported anymore. It's about 2 years since it's had any maintenance, although it works fine. It doesn't support the very latest version of Docker Compose, which for us is still fine. Mock SSE, the guy went AWOL or disappeared on that, didn't want to maintain that, so I picked that up and that was pretty much a rewrite. So that allows us to mock our server-sent events out. Cucumber, which we're using as well in the application tester, took some functionality away, some undocumented functionality that we were using away that we depend on, so I had to rewrite that. And a bit of other stuff. The happy upgrade from 18 to 20 I thought was going to be a bit painful, but it was painless. A few hours. Keeping relationships alive. I haven't been so good at this. So I've basically been buried for about 2.5 years working on this. Yeah, so my wife comes first. That's pretty much the only relationship I've really kept alive. I've had very little time for running OWASP Christchurch and InfoSec NZ, but we've got some awesome InfoSec NZ admins which have more than picked up the slack. One of which is over here. Yeah, so now that we're at Alpha, hopefully things are changing a little bit and I'll be becoming a little bit more visible again. So keeping yourself alive during a project like this. So Purple Team was pretty much, to the Alpha stage, has been done sort of as, I've been done in my spare time and when I haven't had like consulting jobs on and stuff like that. So eating right is super important, getting enough sleep and fitness. So I spend like 2 hours at the gym 6 days a week. Without doing these 3 things, my health would plummet and I just wouldn't be able to do it. I've actually been working like 7 days a week for as long as I can remember. So competitors, when I first started this, it was BDD Security. They seem to have disappeared now. I can't find that they actually are continuing on with the tool that I thought, well, yeah, the tool that they were working on at the beginning. That was my only real competitor at that stage. Now we've got Stackhawk, which has recently recruited Simon Bennett, the iOS Zap creator. And we've got GitLab, which has a dynamic application security testing component on Ultimate. And as far as I know, there's nothing else that, correct me if I'm wrong, I'd like to find out if there are some other competitors that are doing pretty much what I'm doing, or to keep an eye on them anyway. So Purple Team's standalone and it only does one thing, so I'm hoping it's not going to be too difficult to get into your build pipelines and get going with it. Shout-outs, big shout-out to Craig Rowland of Sandfly Security. He helped me as a mentor, especially in early stages. He's probably thinking if he hears this, what? But yeah, he helped me with some really good advice up front. Simon Bennett and Ricardo from the Zap core team have been super helpful with debugging Zap and just super friendly. Leanne Carter, my wife, she's my rock. And Aksath Kathari, which is a fellow that's come on board recently to help engineering Purple Team. So what are the next steps for Purple Team? So Purple Team Local is now an OWASP project as of about a week ago. So we've now got a project page there together, and yeah, we're hoping that people are going to start using it, start contributing and that sort of thing. So how can you get Purple Team into your build pipelines and your applications that you use to test your other applications? So as I discussed earlier, so there's 2 environments, local and cloud. Local is set everything up yourself. Cloud is sign up for an account set up your test job, and get the CLI on your system. So a couple of ways you can get to using it. So contributing, there's a whole lot of avenues there. So GitHub discussions, which I've just set up on our repository. There's the official OWASP Slack with a Purple Team project in there now. So we're using project boards on the actual Purple Team repository for everything, to triage everything, which is basically just orders your issues. You can submit pull requests, you can report security issues. There's a responsible disclosure page. There's a public roadmap as well, and contributing guidelines. So if it's missing something you need, or you find a bug, or the setting up docs are not clear enough or something, jump on me and let's get it fixed. Or if you need to add additional testers, same deal. It's open, so you can add them yourself, or just open an issue to have it done. So next steps for Purple Team, a proper docs site. So we've got a docs site there at the moment. It's just basically, it's a GitHub repo that's hosted, and it's at doc.purpleteam-labs.com. Purpleteam-labs, I'll show you the URL soon. Proper landing page. Yep, so if you're a developer, or you're in a development team that wants to give Purple Team a spin, come and see me afterwards, or jump on InfoSec NZ, or get in contact with me somehow. There's plenty of ways you can get in contact with me. So we're always looking for good people to help contribute. Even if you're a student, it's a great way to learn how to get into secure coding by actually creating something like this. That's the URL. If you want the docs, then you just put doc on the front, although if you go there, it's got a link to docs as well. And that's it.